Hello, and welcome to another digital lecture for Salt Lake Community College. This lecture will continue to cover Section 2.3 for Introduction to Statistics, Hypothesis Testing. Now that we have covered the basics of hypothesis testing, let's examine a common situation involving the U.S. court system. When a person is accused of a crime, it is common for the U.S. court system to conduct a jury trial. In a jury trial, the court considers two possible claims about a defendant. They are either innocent or guilty. If we set these claims up in a hypothesis framework, a defendant is considered innocent until proven without a reasonable doubt that they are guilty. Thus, a jury considers whether the evidence is convincing enough, strong enough of the person's guilt. This is the alternative hypothesis. Thus, in a jury trial, our two hypotheses are going to be the null hypothesis, the defendant is innocent, versus the alternative hypothesis, the defendant is guilty. Now we consider the evidence, the sample results, and the prosecutor's ability to make a strong case. There are two possible outcomes. First, the prosecutor gives convincing evidence of guilt beyond a reasonable doubt, in which case we would reject the null hypothesis of innocence and conclude there is sufficient evidence that the defendant is guilty. The second possibility is that the prosecutor's evidence is not strong enough, not beyond a reasonable doubt, in which case we would fail to reject the null hypothesis of innocence and conclude there is insufficient evidence that the defendant is guilty. Notice we're not saying that the defendant is innocent. We're saying there's insufficient evidence that they are guilty. Now, in general, there are three ways that we set up and compare our null and our alternative hypothesis. First, we have equal versus not equal hypotheses. This is called a two-sided test because you can be not equal by being greater than or by being less than. And so we must consider both possibilities, two sides. We also look at equal versus less than equal. And then lastly, we look at equal versus greater than equal. These second two are referred to as one-sided tests because we're only considering one direction. Notice that in all three of these forms, the null hypothesis always contains an equal sign. And the alternative hypothesis is either not equal, less than, or greater than. Thus, when you are writing your hypotheses, you must determine which inequality goes in the alternative hypothesis based on the scenario we are looking at. After writing our hypotheses, we then consider the evidence. If the evidence is close to what the null hypothesis states, you do not reject H naught. Again, you don't say you accept it. We have never proven it. we just say we do not reject it. In which case our conclusion is there is insufficient evidence to conclude that the alternative hypothesis is true. Alternatively, the evidence could be far away from what the null hypothesis states, in which case we reject the null hypothesis and conclude that the alternative hypothesis is true. In our conclusion, we would state that there is sufficient evidence to conclude that the alternative hypothesis is true. Let's look at a couple examples to practice. According to the MyPlate recommended guidelines, 20% of daily nutritional intake should be from protein. A dietitian believes that Americans do not consume the right amount of protein and wants to estimate the percent of their daily nutritional intake that is from protein. Let's first identify the parameter of interest. Here, the dietitian wants to estimate the percent of their daily nutritional intake that is from protein. Now, while it does say percent, I identify this as a proportion. So the parameter of interest is going to be the proportion of an American's daily nutritional intake that is from protein. Our null hypothesis will be that the proportion is equal to 20%, to 0.20. Remember, your null hypothesis is always a statement of equality. Versus the alternative hypothesis. Here we must decide which inequality to use. Recall that the dietitian believes that Americans do not consume the right amount. You could not consume the right amount by consuming too much or not enough. This tells us that the alternative hypothesis is that the proportion is just not equal to 20%. This tells us that we are looking at a two-tailed test because we must consider both possibilities of being greater than 20% or less than 20%. Now we must consider the types of errors that can be made. Recall a type 1 error is when you're rejecting the null hypothesis when it's true. We would like to state this in context of the problem. So a type 1 error would be concluding that Americans' daily nutritional intake is not 20% protein, when in fact it really is 20% protein. A type 2 error, recall, is when you're failing to reject the null hypothesis when it's false. You're failing to reject it when it's false. In context of this situation, it would be concluding that Americans' daily nutritional intake is 20% protein when in fact it is not 20% protein. Now, when considering a hypothesis test, we should consider what alpha is, the probability of making a type 1 error. In general, we will choose our alpha in context of the situation, depending on which type of error is worse. In this situation, a type 2 error would be worse, since if you have health problems that you can't trace, it could be because you're not consuming the correct amount of protein when you think you are, in which case a larger alpha should be chosen. maybe something like 0.05 or 0.10. Now let's consider what our conclusion would be if your null hypothesis is rejected. If you reject your null hypothesis, then in context of this situation, we would be saying that the dietitian concludes that there is sufficient evidence that Americans' daily nutritional intake is not 20%. If we're rejecting the null hypothesis, then we're saying their daily nutritional intake is not 20% protein. Let's look at another example. I would like to give you a moment to practice this example on your own. So it might be a good idea to pause the video for a minute and consider what your parameter of interest, your null and alternative hypotheses would be. What would be a type 1 and type 2 error in context of this situation? And your conclusion if the null hypothesis is not rejected. So please take a moment, pause the video and consider these questions. And then after you're finished, come back, unpause the video, and we'll see how we do. I'll see you in a moment. Okay, I hope you paused your video and considered this example. Let's see how we did. A particular drug is known to be effective against a particular disease. However, a researcher believes that a majority of patients are experiencing undesirable side effects and think the drug should no longer be prescribed. Let's first identify the parameter of interest. And I'd like you to be explicit on what the parameter of interest is. Here, our researcher believes that a majority of patients are experiencing undesirable side effects. Now, a majority is a proportion. A majority would be more than 50%. So here, our parameter would be the proportion of patients that are experiencing undesirable side effects. Please be explicit with your wording. Now, your null hypothesis would be that the proportion really is 50%. The alternative hypothesis. Remember, our researcher believes that a majority is experiencing these side effects, and a majority would be more than 50%. So our alternative hypothesis would be P is greater than 50%. Because we're looking at when the proportion is greater than 50%, we know this is going to be a right-tailed test. Now let's consider the types of errors that could be made. Remember, a type 1 error is when you're rejecting the null hypothesis. You're rejecting the null hypothesis when it's true. In context of this situation, your type 1 error would be concluding that a majority of patients are experiencing undesirable side effects, more than 50%, when in fact it's not a majority, not more than 50%. A type 2 error. Recall, a type 2 error is when you're failing to reject the null hypothesis when it's false. You're failing to reject the null hypothesis when it's false. In context of this situation, It'd be concluding that a majority of patients are not experiencing undesirable side effects, when in fact the majority is experiencing undesirable side effects. Now let's consider what alpha would be. Now remember, alpha is the probability of making a type 1 error. But we choose alpha depending on which type of error is worse. So when considering these errors, you'd like to think which type of error is worse. Now here, I think a type 1 error would be worse, since they would stop prescribing the effective drug when the side effect actually doesn't occur for most people. In which case, a smaller alpha might be chosen, something like 0.01. Now let's consider what our conclusion would be if the null hypothesis is not rejected. And we want to give our conclusion in context of this example. We could say that the researcher concludes that there is insufficient evidence that a majority of patients are experiencing undesirable side effects from this particular drug. Okay, this about covers all the definitions and examples that I have for section 2.3. If you have further questions, be sure to review the example videos that follow or ask your instructor.